Hey guys, this is Mrs. H. I am going to just show you guys again how to do predicting products for double replacement reactions. So this is a specific type of double replacement reaction where it's an acid. I know it's an acid because it's starting with an H. And I know this is a base because it has OH. So a double replacement, remember, is when the cations switch spots. And for the specific, this type, you're always going to end up with water. And it's helpful to write water as HOH for balancing purposes. So the H came over and it was right here with the OH. And notice I don't have that 2 anymore. This 2 doesn't really belong to the OH. It belonged to the barium, which was +2. So when I get here, I can have, this would be my thinking. I know hydrogen is plus and hydroxide's minus. So water is H2O or HOH. So the other part then I need to put together is this part, the barium with the hypochlorite. So barium is right here, and I know it's +2. And the hypochlorite is somewhere in here. Not finding it right there. So I know it's ClO with a -1. So that's what's going to go in this other blank. My thinking is, okay, I got to put my cation first, my anion second, and then I have to balance charge, which I can crisscross, or just think I would need 2 of these for every 1 of these for myself, for that to be electrically neutral. So again, here's this specific type of double replacement is acid-base neutralization because you get water and a salt. And the salt is just any ionic compound. So let's balance always. You can see when I balance this, I'm going to balance the OHs as one thing, and then I'm going to do the H as another. So I can see, like here I have 2 ClOs, so I'm going to need to put a 2 here. So now I have 2 ClOs and I have 2 H's of the green H. So I'm going to need to put a 2 here. So now I have 2 hydrogens, but I also have 2 OHs, but I have 2 OHs here, and 1 barium, 1 barium. So I'm balanced. So here's another example of a double replacement reaction. This one's not an acid-base neutralization, but it still works the same way. So the first thing I'm going to do is write the formulas here. Aluminum is right here. It's +3. Iodide is iodine, which is -1. So I know my formula is going to be Ali3 plus mercury, Roman numeral 2, means it's +2. Chloride is here, which is -1, so I would need 2 of those. So then I have to think about the aluminum is going to switch places with the mercury. And then I'm going to form 2 new compounds. So when I get over here, I want to put the aluminum with the chloride. This is my thinking. You can, this would be your scratch work. So notice I didn't bring the 2 with, because that 2 is only there because mercury was +2. So now, to balance charge, this would have to be AlCl3. I would need 3 of these for it to add up to 0. This is just gone now. That was my work. The mercury is mercury 2, which is down here somewhere on our pink chart. And that's going to go with the iodine, which is -1. So I can crisscross, and I want to balance the charge, so I'm going to need 2 negative iodides for every 1 mercury. So these are my products. Cation goes first. Notice I did not bring those subscripts over. I refigure out what the subscript might be based on the charges. Now I can balance, and you can see that let's start with iodine. I have 2 iodines here and 3 here. So a number that they both go into would be 6. So if I were to put a 2 here, 2 times 3, I now have 6 iodines. And if I put a 3 here, 3 times 2 is 6 iodines. Now I'm going to balance the aluminum. So I have 2 aluminums there, and I only have 1 over here. So I need to put a 2 here. Now I have 2 times 3, I have 6 chlorines. Over here I only have 2. So if I put a 3 here, I now have 6 chlorines, and I have 3 mercury, which works out because I have 3. So I am balanced. I have one more double replacement example that I'm going to do with you, and it is this one right here. It's a double replacement. It's not an acid-base neutralization, but it's done in the same way. So the first thing we're going to want to do is write the formula. The chemical formulas. I'm going to do them up here this time. So I know that silver, I'll just kind of write over this, is +1. I know nitrate is -1. So the formula is going to be AgNO3 plus, and here I know potassium is plus, it's in this column. Phosphate is over here somewhere, which is PO4 -3. So I'm going to have 3 Ks for every 1 PO4. So that was my first step. Now I'm going to think about what's going to go on. The cations, or the first part of the compound, are switching spots. So the silver is going to go with the PO4, potassium is going to go with the NO3. When I come over here to write these 2 formulas, I do not bring those subscripts with unless it's part of the poly, which PO4 that 4 is, NO3 that 3 is, so those are going to come with me, but over here, this is not part of a polyatomic ion. So I'm going to put the silver, this is my thinking, with the phosphate. And to balance charge, my formula would be Ag3PO4. Then I'm going to put my potassium, again, this is my thinking, with the nitrate. They already add up to 0, so it's just going to be KNO3. Then I want to balance, and when I balance, I'm going to start with my silver. I have 3 Ags. I'm going to put a 3 here. Now I have 3 NO3s. Only have 1 here, so I'm going to put a 3 here. Now I have 3 potassiums, and I have 1 PO4 and 1 PO4, so it's balanced.